This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
What kind of data do you collect? So you're looking at homes that have survived, homes that didn't, buildings and infrastructure like schools and hospitals. What kinds of data are you collecting, and then what do you use it for?
Sure. So, um, depending on the project,
We'll be
depends
here
on
for the
the
next
data we
hour, right?
collect. So, I can start with what we kind of collect, what kind of data we look at for water infrastructure. In that type of work, we are testing at varying different scales. So we'll test pipes in a small furnace at Oregon State University, and then we'll test pipes connecting, so some pipes to the back of, a building that's being burned on fire as part of an experiment. So we tested all sorts of different scales. And so for our pipe tests, we collect data on, flow rate of depressurization. We collect data on volatile organic compounds. We have the water tested by an independent laboratory. We collect data on temperatures of the fire itself, um, heat flux. For the vast majority of the
Ooh,
audience.
you're getting my mechanical engineer senses tingling. Ooh, heat flux. Excellent.
I know civil engineers don't take thermodynamics, so we don't always know what this means. But for earthquakes, we use the intensity of the earthquake. We talk about ground acceleration. And the colloquial terms when we talk to the general public, we use moment magnitude. Now, when we talk about fire, heat flux is almost like our ground acceleration. And so that is going to tell us about the intensity of the fire itself. It's the amount of energy that's being released per unit area that's being burned. Temperature, you can reach the same temperatures at different heat fluxes. So, the temperature is something that the general public understands, but it really doesn't tell you much about the
No.
intensity of the fire
It's the
itself.
difference between your home oven and a wood-fired pizza oven. You can reach the same temperature, but one it's gonna cook your pizza a whole lot quicker.
Yes, exactly. So we do a lot as it pertains with heat flux. And that's usually what we categorize the fire as. And it's a way for us to distinguish the intensity of a fire that might be a resultant of a grass fire or a forest fire versus a building on fire. And so the heat fluxes are going to be vastly different. But you might see similar spikes in temperatures.
Mhm.
Between the two. So
Do you also see different heat fluxes between different species of trees? I'm thinking about we've here in Oregon, we've got like noble fir, some lodgepole pine, Doug fir, all those kind of things. But then, Colorado, I think this picture is from Colorado. You've got aspen and other things. Are you seeing different heat fluxes depending on the makeup of the forest as well?
I'm sure I don't collect data on that. So we very much operate within the confines of the community. But as you do vary the vegetation, you are going to see varying heat fluxes. I doubt it's anything drastic. As it's not going to swing as much as a grass fire versus a building
Mhm.
fire. And just to give, the audience some perspective, a grass fire might be like 15 kilowatts per meter squared. And then, a home fire could be anywhere from like 80 to 100.
Oh,
So
wow.
we're seeing huge differences here, right? Fire moves very quickly through the wild land, but our homes are burning for hours, just sitting there. And so it's a completely different fire situation when you
Hmm.
start looking at the fire within the community versus the fire in the wild land. So you have to collect all this data to be able to actually characterize the fire and provide context to which you're presenting your results.
Right.
So that's on the water side. The pipe material is also very important for us on the water side. On the building side, characteristics of the homes we might collect is the distance between all of the structures. So distance in different directions, and the direction matters because wind matters. And so
Yeah.
you kind of want to understand how the fire is propagating. We look at siding material, roofing material. We look at anything that is within 5 feet of the house. So if there's a fence or a deck, is the fence touching the home? What's the material of the fence? What's the material of the deck? What type of vegetation is
Yeah,
around the
blackberries growing
house?
over it.
Exactly. Yeah. I mean, do you
I'm
have
looking at my
trees
fence
over
right
the
now
house?
going, ugh.
Yeah, what's there, right? Because we're trying to characterize the ignition potential of the house. Unlike wind or earthquake, we don't have sensors in our communities for fire. So when there is a fire, we have no idea what the intensity of that fire was in the community because there are no sensors in the community. So we
And
have to collect
it
all this
also
information.
sounds like there may not be, something like the Saffir-Simpson hurricane scale or the Fujita scale for tornadoes, the F number or the category of hurricane that we've heard is sounds like there's not something similar for wildfires.
There is not. There isn't. So that makes it really difficult for us to even have the conversation of how do you compare these fire, even just the Palisades fire versus the Eaton fire. How do we compare those two fires that occurred a month ago to one another? We don't have vocabulary to do that.
Yeah.
So we have to collect all this information to begin to start sussing out what the intensity of that fire might have been, and then couple that with all of our climatic data and weather data, and that will give us the fuller picture of what happened.
This is get this is getting me really excited because this
Okay.
is like, if you're an engineer listening to this, you're like, whoa, we've got like, a whole career worth of problems
Yeah.
to
Yeah. This is
solve,
why we
right?
need engineers.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NARI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NARI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.